Hello. This is the lecture on Chapter 2 of YaRrr, the Pirate's Guide to R. And today we're going to be covering most of the basics of coding in R and how to generate simple vectors of numbers. But before I get started with that, I want to quickly dispel some concerns that some people might have, especially if if you're new to R and you're used to using other languages such as SPSS, though I don't even know if I should call SPSS a language, but yeah. So if you're used to using SPSS, then you might find that you're struggling a bit as you get started with R. And I can really show you how that's going to look using a plot, because of course we like to do that in R. First, to create this plot, I need to use the YaRrr library, which if you don't have that installed on your machine, then you can just install the package using this code up here, which I've commented out. In the previous lecture, I discussed how to install the package. But let's create the plot. So here, I'm going to show progress over time in programming or getting whatever tasks you have done using programs. So on the x-axis here I have time, could be days or weeks, and on the y-axis we have progress. So first let me add the SPSS line. So this is how typically I would think someone would progress with SPSS. That they start off with really a huge jump, that they learn a lot of cool things, how to run t-tests, create plots, and because it's all menu-based, it's all very user-friendly, you pick up things pretty quickly. But over time, the gains that you make really start going down, until you start leveling off when really you've reached the limit of what SPSS can do, and you struggle to learn anything new. Now let's add the progress for R. And here's, I think, how the R progress line looks like. And the main thing here is that, yeah, for the first few days, weeks, or months, depending on how much time you have, of learning these software, that you'll find that the progress with R will start off being really substantially lower than SPSS. If you take one person learning R, one person using SPSS, you might find that the person using SPSS learns how to do things a bit faster than the person learning R. But what I guarantee you is that over time, at some point, the person learning R is going to match all the abilities of someone using SPSS, and then what's great about R is that instead of SPSS, where the longer you go, the less you can learn, with R, the more you learn, the faster you're learning more things, and really what you can do skyrockets to the point where you can do anything you can imagine and more. And I know this is probably a bit over the top, but I really want to emphasize that when you're learning at first, you're going to really be struggling, because you might be on this lower curve here, and you'll see maybe your other SPSS self that knows how to do SPSS. You'll say, yeah, but I know how to do this in SPS, and I don't know how to do this in R yet. But trust me, just wait, keep up with it, and soon, once you get up on this higher end of this curve, you're going to be taking off. So stick with it. Don't get too frustrated. Okay. So now that we've explained that, let's open up a new programming window in the source. So I just do that by opening up a new R script in RStudio. So new script. I already had one open, so I can just close that. So first, I'll just start off by adding a title to this document, again with commenting. So I'll say Chapter 2 of YaRrr, the Pirate's Guide to R. Okay, now if you've looked at the previous lecture, you already know the basics of the windows in RStudio. Again, this is the console. This is where R is going to be evaluating your code. This is the source where you're going to be writing most of your code while it's being sent to the source. And this window has plots, and you can look at packages, things like this. So the first thing about R is that you can use it like a basic calculator. 1 plus 1. And I highlight this code and click Run to send it to the console. It's 2. R preserves orders of operations. 8 plus 9 times 3. Run that. And it gets sent over to the console. Now again, when you're writing code in R, use the # to indicate comments. So now I'm calculating 1 plus 1. This equation is also very important. And then I can just select all and run it to the console. Again, to select all, I just, on my Mac, held down Command A to select all, just like in any other program. And to send it to the console, I use the hotkey holding down Command and hit Enter. And because I have this non-R code commented, then I don't get any errors. If I take away these comments, then I run this, then I get all kinds of errors because R says, wait, now I'm calculating 1 plus 1, that's not R code, and it gets all confused. So let's go ahead and re-comment these. Okay, so first some code formatting guidelines in R. So to some extent, the R language is very specific in how you write things. If you use improper R code, you'll get errors. On the other hand, there is some flexibility in how you format code. So for example, R ignores spaces. So if I say 1 plus 1 or 1 space plus 1, both of these, I get the same result. So if I'm writing some long equation, I can just keep writing numbers and R will run it. But it's good to get into some habits of using spaces to make things look better. So for example, you should always put at least one space between basic operations, 10 minus 2. Yeah, because R will ignore the spaces and it just looks a bit more pleasing to the eye. So use spaces when you can. Okay, so far we know how to use R like a calculator. Let me clear this. Now let's go into our first R-specific function, which is object assignment with the arrow. And the way object assignment works is that it's a way for you to store certain information as something else in R that you can refer to later. And the way to do that is by using the arrow symbol. So for example, let's say I want to save an object called myAge, and I put the arrow and I say 32. So what R is going to do, it's going to say, okay, here's my new object, which I will call myAge, arrow sign 32. So now it's going to store, when I send it to the console, my age is 32. So now, if I just type my.age, and I run this, then I get a result of 32. Now, once I have it saved as an object, I can then use that in other operations. So I can say if I want to know how old will I be in 10 years, if I'm really bad at math, I can say my.age plus 10. And I will be 42. I think that's the age of Homer Simpson. If that's the case, then I gotta make good use of this next 10 years because Homer didn't look too good. Anyway, he's a funny guy though. Okay, so that's how object assignment works. You're gonna be doing this a ton in R. And this is, I think, one of the great things about R and other basic programming languages, aside from SPSS and Excel, things like this, that you can store pieces of information as something you name and then later on use it with other commands. Now, there's a few rules to naming objects in R. The first thing is that they can't have spaces. So I can't say my age is 32. If I try that, I get an error. So no spaces in object names. You also can't start an object name with a number. So I can't say, let's say I'm recording mean values of different groups from some data set, and I might say one group.mean, and I want to say it's 5. Well, that's not going to work because I started it with a 1. So instead I should say group 1 mean is 5. And if I run that, that's fine. So don't start it with a number. And there's also a few special characters you can't use. So for example, I can't say my age exclamation point is 32. If I try to run that, I get an error. So don't use special characters. I would generally restrict yourself to lowercase letters and periods. I think this is the best way to do it. Now, another thing with assigning objects in R is that it's case sensitive. So if I have an object, let's just call it A, and let's just assign it to 10, and I run that, okay, R has stored A as 10. Now, if I want to see, now let's assign capital A to 15. I send that, okay, so now capital A is 15. If I just look to see what the value of A is, let's run A, I get 10, capital A, I get 15. So this is very important to keep in mind. Also, several functions in R, you need to make sure that you're writing them with the capital, whether it's lowercase or uppercase. For example, there's the view command to look at a data set. So in the YaRrr package, there's this movies data set. If I say view movies, then I get an error because R doesn't know what the function view is. That's because I forgot to capitalize it. So if I say view with a capital V, movies, and I run that, then I see the data set. So always keep in mind whether an object name or a function that you're trying to use has a capital letter. And it's not just if it's the first letter or not, if it's anywhere. So for example, if I said my name is Jack Sparrow versus my name, Blackbeard. Spelled Blackbeard wrong. So these will be two separate objects. So say my name is Jack Sparrow with capital letters for name, but my name with undercase is Blackbeard. Okay, so that's how to create basic objects in R. And once you've created them, you can then use it in other commands. So again, let's say A is 100. Now I can say A plus 100. And if I first run A is 100, A plus 100, I get 200. I can also create new object using previous objects. So I can say B is A divided by 3. Okay, so now I'm assigning the value of the object B to be A divided by 3, which should be 100 divided by 3. So let's look at B, and I get 33.333. Now let's say at some point that you want to reassign an object. So right now, if I look at A, it's 100. If I want to change it, I can just reassign it. So now I can say A is, I don't know, whatever I want, 88. Now if I look at the value of A, I get 88. Now you'll notice that I'm typing a lot into the source here, which is a good habit in general because you want to save what you've done. But if you're just checking things and you don't need to save it, you can also just type directly into the console. So I can just say A here is 88 if I was checking that. I don't necessarily need to put it here. Okay, so let's do a quick example of this. So let's define a new object called blackpearl.usd, and we'll assign it to be the total revenue of Pirates of the Caribbean 1 Curse of the Black Pearl in US dollars. And when I searched for this on Google, I found that the revenue was $634,954,103. Now you'll notice I didn't include commas in the numbers, and you definitely don't want to do that in R. Anytime you're writing even a long number, don't include commas, otherwise R will get confused. So now I've stored that value, and I can check to make sure it worked. Actually, because I didn't see any error, I know it stored it correctly. So to see what the value is, I can just run it, and I see that it's correctly stored it. But now let's say that one of my European colleagues wants to know, well, how much was that in euros? So if I know the euro to dollar translation rate, then I can easily do that. So let's say euro to dollar. And when I just checked this on Google yesterday, I saw that it was 0.88 euros, 0.88 euros per dollar. So when I save that, I can save that conversion. And now if I want to create black pearl in euros, I can just say black pearl USD, times euro to dollar. Let's run these. And now we can look to see how much it is in euros, and we see that it's 558,759,611 euros. Okay, so that's how you can do basic object assignment and combine objects. So far the objects we've been using are all numeric, so they're all numbers. But you can also have objects as strings. Strings are also known as characters. So let's say I want to store the name of an actor in a movie. I can say actor is Johnny. I don't know how to spell Johnny. Is Johnny Depp? Oh, let's just say it's that. Johnny Depp. And movie is Black Pearl. And I can save these. And now anytime I want to know the name of the actor that I've saved, I can run that and I see it's Johnny Depp. So anytime you want to define something that is a character, you always want to use quotation marks in R. And you can save objects as strings using that. But the object itself will always, will never have the quotation marks. So anytime I want to look at the value for actor again, I need to write actor without quotation marks. If I write actor with quotation marks, now R thinks I'm just defining a new string called actor. It doesn't know that I'm referring to the object that I've defined before. To do that, you need to write it without quotation marks. Okay, so now we've covered basic object assignment. And so far, the types of objects we've been covering, I'm going to clear all this, have just been single-dimensional objects. So these are called scalars. And these are objects with one dimension. So here are some examples of scalars: 100, ship, black, pearl. Yeah, these are all just scalars. There's just one thing in it. But what you'll be using a lot in R are multi-dimensional objects. And the simplest multi-dimensional object is a vector. So this is an object with one, or actually really scalars are objects with no dimensions. So it's just one thing. And a vector is an object with one dimension, which is length. So a vector could be, and this won't be proper R code, but could be a list of the numbers from 1 to 10. So I could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We might want to store all these numbers into one object. Now, what you might want to do is say, let's say 1 to 10, and try to store it like this. But this doesn't work in R. It's going to get confused. And the reason is because we haven't used proper R code for defining a vector. And there are several different ways to define vectors. And the easiest way is to use the C function. And this is quite simple. So if I want to define the object 1 to 10, then I use the assignment, and then I just use C parenthesis. And then I put in the objects I want separated by commas. So I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And when I run this, then this vector has been assigned to the object 1 to 10. Now just to see what's in it, 1 to 10, I enter that, and now you can see that it's the vector from 1 to 10. You can also use the C function to create vectors of strings. So I'll just say string vector, or vec, and I'll say it's, I don't know, apple. Let's call this fruit.vec. Apple, banana. There are two. No, how do you spell banana? Okay, I think that's right. Lemon. And when I run this, then this vector of strings has been stored in fruit.vec. And if I look at just fruit.vec, I see that it's got them. Now, one thing about vectors is that they can contain either numbers or strings, but they can't contain both. If you try to put both numbers and strings into a vector, then R will convert everything in the vector to strings. So if I had, for example, movie revenues, and I wanted to say, okay, first, Black Pearl, I'll just make up a number here because I forget what the actual value was, and I'll say 100. And then I had Dead Man's Chest, and let's say it was 200. and I tried to store all of that, R will happily store all these into a vector. But now if I look at what's in movie revenue, I see that the numbers, in this case 100 and 200, are now stored as strings. And if this is okay for you, that's fine. But if you then try to do numeric operations on these numbers, R will get confused because it thinks that it's just a string. So for now, don't need to worry about it, but later on this could become an issue. Just keep in mind that vectors are stored either as strings or as numbers. If you try to put both into a vector, then it will store all of them as strings. So this is this C function, or concatenate or combine function, is the most straightforward way to create vectors, but it's also the most slow. So for example, when I tried to create a vector from 1 to 10, I had to type each number individually and put a comma between them. That takes a little while. So thankfully, R has a lot of other functions that allow you to easily create vectors of numbers. Now, one of the easiest functions is this A to B function. And the way that works, we can look at the help menu, or how do you look at the help menu for A to B? To be honest, I don't know. That one's hard, but I'll just show you how it looks. So in this case, A is just the start of the sequence, and B is the end of the sequence. So for example, if I want to write 1 to 10, I can just do 1:10, and I'll send that. And as you can see, I then have a vector of the values from 1 to 10. And again, I can just store this. If I want to store this as a vector, I can say 1 to 10 and assign 1 to 10. So as you can see, this function, A to B, will always create a vector from the first number to the last number in steps of 1. I could also say 1 to 100, and I get all the integers from 1 to 100. But I don't necessarily need to start and end with integers. I can say 1.2 to 100.2, and I get the numbers from 1.2 to 100.2 in steps of 1, but now it's each number has 0.2 after it because I started with 1.2. I can also go backwards if I want. So I can say 5 to 1, and I get 5, 4, 3, 2, 1. Just have the start number be higher than the second number. So that's another easy function for creating sequences of vectors. But what if you want to create a sequence where the steps between the numbers is not 1? To do that, you should use the sequence function. And we can look for help on the sequence function by typing $seq, and you can see some help menu for the function. And this function has several arguments. The most important ones are this from and to argument, which is just like an A to B saying what's the starting number, where's it going, sequence going from, and what's the ending number, what's it going to. So I can say sequence from equals 1, 2 equals 10, and I get the same vector as before. But this function also has other arguments that I can use. For example, it has this argument by, which is the increment in the sequence. So let's say I want the sequence of the numbers from 1 to 100, but now instead of steps of 1, I want steps of 10. I can say by is 10. If I run this, I get 1, 11, 10, so now 21. So now the steps are in 10. Let's try again. So I can say from, let's say I want all the even numbers from 1 to 100. I can say sequence from 2 to 100 by equals 2. And I get all the even numbers from 2 to 100. Now, so by is one of the special arguments in the sequence function. Another argument you can use is this length.out function. And the way what that means is it will tell you, or you can define where you want the sequence to start, where you want it to end, and what the final length of the vector should be. So let's say I want the numbers from 100 to 1000, but the resulting sequence, I want there to only be 5 numbers. So I can say length.out is 5. And what this will do is create a sequence from 100 to 1000 and there will be 5 numbers in the sequence, and the step size will be equal between all the numbers. So in this case, it looks like from 100 to 325, the step size is 225 between each step in the sequence. Okay, so we can, so that's the sequence function. That's also very helpful. The next sequence generating function we might want to use is repeat. And repeat has 3 arguments. Let's look at the help function for repeat. So repeat allows you to replicate elements of vectors or lists. We can ignore lists for now. So let's say we want to, for example, repeat the number 2 10 times. So we can say repeat x equals 2 times 10, and we'll repeat the number 2 10 times. So in this case, I've just repeated a single scalar, but you can also repeat vectors. So let's say, for example, you've got a batch of 10 new pirates coming to your ship, and as they're walking onto the ship, you need to assign each of them one of 3 jobs. So let's say we want just a vector of numbers where the jobs, let's say, are 1, 2, 3, and we want a vector that says 1, 2, 3, 1, 2, 3, 1, 2, 3, and then I can just read these off. So I can say pirate jobs.num and assign that to repeat. And now I want to repeat a vector, so I can just say repeat 1 to 3. Again, we're using the a to b function from before, and length that out is 10. So I want to repeat the sequence 1 to 3, and the final length of the sequence should be 10 because I know I've got 10 pirates coming on. Okay, so that's done. Now let's look at the result, and you see that we have a vector of length 10, and the first pirate will get job 1, second will get job 2, third gets job 3, and now the fourth pirate gets job 1, so we have an even distribution. But we can also use repeat with string vectors. So let's say I want to repeat this, but now I want to say pirate jobs, let's say text, and now we'll have this look the same, but now instead of repeating numbers, now we can have text. So let's say the first job is deck swabber, the second job is parrot groomer, and the third is our pirate app developer. Okay, and we want length.out to be 10. Let's create a little more space here. Okay, so let's run this code. And now if I look at the result from pirate jobs text, then we see that the first element is deck swabber, second is parrot groomer, third is pirate app developer, and then it goes back to deck swabber and so on. So we can easily use text as well. So that's using the length.out function, or length.out argument in repeat. You can also use this times argument. So what this says is just going to say, how many times should I repeat this sequence? So let's say I want to repeat the numbers 1 to 5, and I want to repeat that sequence 3 times. Then I just say x is 1 to 5 times is 3, and I just ran this, and you'd see that the resulting vector is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that's how the times argument works. The only difference between times and length out is if you know explicitly how long you want your sequence to be, you say length that out. But if you instead don't exactly know how long you want it to be, but you just want to repeat a sequence a certain number of times, then don't use length out, instead just use times. Now the final argument to rep is, well, there's other arguments too, but the main ones you might want to use is this each. And what each does is, I'll just show you an example. So let's say repeat x is 1 to 2, each is 3, and times is 5. And what this will do is repeat the sequence 1 to 2, but now it's going to repeat for each of these values in the vector, it will repeat them 3 times, and then it will repeat everything 5 times. Actually, maybe to make things a bit easier, I can start by just using the each argument. So rep 1 to 2, each equals 3. If I run this, I get, it repeats each element 3 times. So I get 3 1s and then 3 2s. But now if I want this sequence 1, 1, 1, 2, 2, 2, and I want to repeat that whole sequence, let's say 5 times, then I can just run the same code, but now say times is 5. And if I run that, then it will first start with each function, or each argument, to do 1, 1, 1, 2, 2, 2, and then it will repeat that whole sequence 5 times. Okay. Now the last function that I want to show is the length argument. And the length, or length function. And the length function tells you how long a sequence is. Oops, this parenthesis went down here. Let's put that back up here. So for example, let's say I have a vector A, which is 1 to 10. And I want to know at some point, well, how many elements are in A? I can just write length A, length A. If I run this, I get 1. Aha! Why did I get 1 and not 10? Well, let's look at what the value of A is. A is just 88. The problem is I didn't actually run this function yet. So it's a really important thing to keep in mind that if you type code into the source but you don't actually run it, then R won't evaluate it. So in this case, I had previously defined A to be a value of 88. I ran length of A, and it said, okay, well, that's just 1. R doesn't know that I want to reassign A to 1 to 10. I need to run it first. So now let's assign A to be 1 to 10. And now let's look at the length of A, and it's now thankfully 10. So this is a nice function that will help you quite a bit. All right, let's go through a couple examples from the book now. So let's say that, well, first let's look at some code and tell me what you think the result will be. So let's say C is 10, C plus 3, and now C. So if I run these 3 lines, what will the final result of 3 be? So make a guess. So now let's run it. Let's assign C to be 10. Now C plus 3, get a result of 13. And now if I run C, I get 10. Now if you made a mistake here, you might have thought that C in the end should have been 13. But it's not, because we didn't actually reassign C to be 13. So if we want to reassign C to be C plus 3, we need to always make sure we include this assignment operator. So now, if we run the 3 of these, then the final result is 13, because now we're assigning 3 to be C plus 3. Okay, so that was more of a coding question, but now let's go through another question. So let's say we want to create the following vector. So 101, 102, 103, 200, 205, 1000, 1100, and 1200. Let's say we want to create this vector in R using both the sequence and the C functions. So this sequence is a bit complicated because, as you can see, the first 3 numbers are in steps of 1, the second 2 numbers are in steps of 5, and the last 3 numbers are in steps of 100. And this would be difficult to do using the sequence function directly, so instead we need to combine it with the C function. So I'll just say my sequence, and we'll sign that, and we'll need to combine these sequences. So let's do the first 3 numbers first. So the first 3 numbers, to do that, we can just say 101 to 103. And if I just run this here, you can see that, yeah, we get 101 to 103. But now the second vector here needs to be 200 to 205. So there's a number of ways I can do this. Actually, probably the easiest way is just to write 200, 205. We could use another function to do that, but since it's just 2 numbers, it's easy. And now the final 3 elements are a sequence from 1000 to 1200 in steps of 100. And if I run this, I should get my last 3 values. And now I want to wrap all of these in the C function to combine them. If I run this, I look at my sequence, you see we get the final result that we want. Now in this case, it might have been just as fast to just use the C function and type all of these numbers by hand. But you can imagine that if this sequence was much longer, 1300, 1400, 1500, I mean, it could go arbitrarily large. You don't want to type all these by hand. So instead, using the sequence function will make things much easier. Okay, so that's the end of the covering of this chapter. So thanks for watching.